Hello everyone, myself Pavani. I'm working as Assistant Professor in CSE AIML Department at MLR Institute of Technology. Today I would like to give a lecture on hidden Markov model POS tagging. In previous video we discussed POS tagging and rule-based POS tagging, stochastic POS tagging. Under stochastic POS tagging HMM. Under HMM we have HMM, how we are applying HMM to POS tagging. This is a major role of the POS tagging. Let's see the overview of today's session. So what is the introduction about the HMM for POS tagging and which type of formulas we are applying and HMM for POS tagging. Let's see the example of the HMM. See the first one, coming to introduction, the goal of the major tag is to assign the mostly likely sequence of a tags to the given sequence. That's what is the major role of POS tagging, to assign the tags to the particular sequence of the words, right? Here, it can be done in two ways, right? HMM is used because it uses two layers of the states. What is the first one? Visible layer and hidden layer. It contains the two layers, visible layer and hidden layer. By using visible layer, we can for the input words and represent the tags. By using hidden layer, we can represent the tags. Let's see, while writing the tags are visible, but during the tagging, they are hidden. Whenever I am training, tags are visible, but training data is not visible during the tagging. Here see, in statistical approach, HMM uses for both lexical properties and bigram. We discussed in previous video, right? Word sequence probabilities and tag sequence probabilities, right? For to get the rule based POS tagging. This we discussed in previous video. See, here I am applying the first lexical probabilities. That means depends on the database, that means word net, frame net. After collecting the words, next I am applying the rules to get the correct POS tag, right? So these are taken from the tagged corpus. See here, let's see. A probability of matrix is used to store the statistical information, right? Here the given sentence contains some W words and tags, that means n number of words, that is W1, W2 and so on Wn, and n number of tags T1, T2 and so on, some Tn, right? See, what is the final probability? Suppose T into argument of maximum of T of probability of T by W, that means tag by words. This is how calculating this. Depends on the Bayes rule. So probability of tags by words equal to probability of words by T into probability of T by P of word. This is the formula we are using entire to find out the probabilities of the tags and words. Here where probability of T by W by T is the words given the tag sequence and P of T is the tag sequence and P of W is the word sequence. This is right. Let's see. This is the Bayes rule, right? Argument of maximum of T, P of W by T into P of T. Let's see the formula here. Assuming the bigramming model contains the depends on the previous tag. Suppose HMM probability formula is P of T. It contains, here I am applying the bigram model. Try to understand the point here. I am applying here to get the probability of T. Probability of T1 is the first word, first tag. Probability of T2 by T1 is the probability of T2 by previous tag. And probability of T3, T2 by T3 is the current tag and T2 is the previous tag. And so on, probability of Tn by Tn minus 1. This is one of the formula to find out the probability of T. Here we have to find out here probability of T by W. Here I am finding out in the probability of T, right? Here next one, when we get the probability of given tags, when by applying the probability of W by T is pi of I equal to n to P of W I by T I. This is the dependency of the corresponding, only the corresponding tag. Let's see final probabilities. Probability of W, T equal to probability of W by T. into probability of T. Already we know the formula for probability of W by T. This is right. We know the formula for P of T. This is the bigram model formula, right? After multiplication this, we can get the final probability. This is the idea behind the hidden Markov model POS tagging. Let's see, we already discussed in previous video how we are finding the transition probabilities. After finding the transition probabilities, we are finding the estimating probability, means emission probabilities, right? How we are finding the estimation probabilities depends on the transition probabilities. Here I am taking probability of Ti by Ti minus 1. That is, here probability of Ti means tags, number of tags. Here n minus 1 tags. Here C of Ti minus 1 comma Ti means count of tagged pairs. That means the sentence contain how many tag or count of tag pairs. Here C of Ti minus 1 is count of the first tag. This is the meaning of the C of Ti minus 1 by Ti slash, that means divide by C of Ti minus 1. After finding these words, we can calculate the P of Ti divided by Ti minus 1. This is how transition probabilities we can get. Next, word tag likelihood. Here see probability of Wi by Ti, that means number of words and number of tags. Here that is the formula C of Wi comma Ti. Here I am taking word tagged pairs. Here I am taking the only tag pairs, but here I am taking the word tag pairs, not the only tag. Here I am taking the word tag pairs. This is the behind the C of Wi comma Ti. C of Ti means count of the tag. Here C of Ti minus 1 means count of the first tag. This is the difference of the transition probability and word tag likelihood probabilities. Let's see, coming to the example. Here I am taking the bird can fly. This is a sentence I am taking, right? Here die is a determiner, we know, right? Bird is a some noun and can is a some modal. That means fly is a verb, right? This is a sentence I am dividing that means I am applying the POS tags, right? This is a possible tag sequence, right? After possible tag sequence, we are applying the some probability of expression. That means probability of T by W equivalent to probability of, this is a formula applying, probability of T by W equal to probability of W by T into probability of T by W. See here, the probability of determiner is some da, right? Some probability of noun phrase is da, right? And next some modal is da followed by the noun. Determiner followed by the noun. Here into probability of the determiner, probability of word, noun phrase. This is how look like the sentence, right? After considering the matrix, probability of DT and noun phrase and modal verb. Here I am dividing the DT is the and noun is the word, bird, and modal is the can and verb is the fly. This is how I am giving, right? Let's see let's find out the HMM for the appropriate tag sequence for the sentence, right? We already discussed here tags and W of, that means words. See, here I am taking one example. In example, I want to find out the transition probability and emission probabilities, right? So, what is the formula? Transition probability P of Ti by Ti minus 1, Wi divided by Ti, right? See, I am taking here one sentence. Some Ted will spot will. Here these are the noun, right? See, assume the POS tag contains a noun and modal verb. Here will is the modal, spot is a verb, will is a noun. Here the will is a name, that means person name. Ted is a noun. This is a sentence I am taking, right? To calculate the probability of the associated particular sequence, we have to require either transition probability or emission probability. Let us find out the transition probability and emission probability. Let's see the first one, how to find out the transition probability. Let's see here, the transition probability contains the, what is the meaning of transition probability? The tag and a tag particular sense sequence, right? That is, the noun phrase is followed by the modal is followed by the verb is followed by noun, right? Here see, these indicate how likely a noun is followed by modal and so on, right? This is the meaning of the sentence. Ted will spot will write. Next see emission probability. See what is the meaning of emission probability? Particular word is generated from a given tag, but here another tag is particular sequence, but here particular word is generated from the given tag. Let's see. Probability of Ted is noun, right? Will is the modal. Probability of spot is a V. Here will is the noun. This is some estimated some. That means the corpus contains this type of data, right? The corpus contains the data counting how often a word is tagged as a particular POS, right? This is the transition probability and meaning, emission probability meaning. Let us find out the example. See, I am taking the some 4 sentences here. So, Mary, John, can see, will, spot will see, Mary, will Johnny spot Mary, right? And Mary will spot, spot, right? These are the 4 sentences I am taking. Here, note that Mary and Johnny and spot are the nouns. That means will are the names, particular person's names, right? See, according to the sentences, I am dividing, that means I am dividing the POS tags. Here, Mary is the noun, right? First one here. John is the noun, right? Can is the modal here. Be is the verb is the C here. And will is the noun. This is the first sentence structure. And next is spot is the noun and will is the some modal. Here not will is the noun, right? According to sentence, what will see Mary, right? According to sentence, the meaning is will is here modal, right? See is the verb and Mary is the noun. After that, will John spot Mary, right? Here will is the noun. Sorry, will is the modal and John is the noun. Spot is the verb and Mary is the noun. Mary is the noun and will is the spot and V is the spot and N is the spot. This is sentence, according sentence, we are dividing the structure, right? See here, in above sentence, word Mary appear. That means, in this sentence, the word Mary appear how many times? So, here 1 time, and the 2 times, 3 times, this is the 4 times, right? This is the 4. In a modal, how many times occur, right? Some 0 times. Mary modal how many times occur? So 0. It be 0. Right? See, Johnny how many times? 1 time. Here 2 times. Right? In modal Johnny 0 0 verb. Next see will. Will how many times occur? As a noun. As a noun will how many times occur? See here only 1 time. Any other option? Any chances? No. Remaining all are modals. See 1 time, 2 time, 3 times. These are modals. Only will occur in 1 time, right? So 1. Next see how many times the will occur in modal. So 3 times. See 1 time, will, 2 time, 3 time. As a verb 0. See spot here noun. How many times spot? Here 1 time. As a noun 1 time, 2 time. Remaining modal 0. But spot as a verb, right? So how many times? 1 time. See the next one. Can. Noun can act as noun, no? So because it is automatically 0, but no one is there, right? Here can occur in modal. How many times? This can occur in here, right? 1 time. But verb 0. See 0, modal 0, but verb 2 times. See 1 time, 2 time. Next spot, noun as 0 and next modal as 0 and but verb as a 1 time. This is the overall structure of the in a table format. Let's see. Let us divide each column number of their appearance. For example, noun appear 9 times. How the 9 times means? Here adding the all nouns. 4 plus 2, 7, 7 plus 1, 8. Sorry, 4 plus 2, 6, 6 plus 1, 7, 7 plus 2, 9. Here 9. Here 3 plus 1, 4. Add the verbs. 3 plus 1, 4. By dividing these two into this table. That is 4 by 9, 2 by 9, 1 by 9, 2 by 9 and 3 by 4, 1 by 4, 1 by 4, 2 by 4, 1 by 4. This is a table. Suppose if the Mary is 4 by 9, will by model, probability of will by model, that is Mary by noun 4 by 9. Same will by model, that is 3 by 4. Like this you can calculate similar probabilities. We will get the final table like this. This is the second step. See, after what is the next third step? Next we have to calculate the transition probabilities. So define two more tags. So whenever we calculate the transition probability, we have to apply sentence starting tag and ending tag by the tags S and E. So S is placed at the beginning of the tag, the sentence, and E is placed at the ending of the tag. Sorry, ending of sentence. See the variations here. This is the transition probabilities. I am adding for each and every sentence before the S and at the end E for each and every sentence. Let us find out the here table, right? Here see, in a structure starting with how many nouns are there? Here Mary, Spot, Mary, like this, right? Here see like this. Like this. This is a main, right? How many times? 3 times. 1 time, 2, 3, right? Here next sentence model contains only 1 time. Verb is 0, right? Ending tag also 0. Let's see noun. Here how many times the noun is there? Here only 1 time, right? Noun and noun. See the here noun. Inside beside it means how many times? Here only 1. Any other place is noun beside, right? No, because it is only 1 time, right? See the 1 time. Here noun model. Here 1 time. Here 1 time. See the noun model. Here another time. But this is a model noun. This is not a correct, right? Only I am finding noun model only, right? This is a 3. See noun verb. Noun verb this is a only 1 time. Any other chances is there? Noun verb. No other chance is there. So this is a 1. Next see the noun and end. Noun contains a end tag. This is a 1, 2, 3, 4. This is a how we are calculating the emission probability, that means transition probabilities in a tabular format. See, this is a 4, right? See next one, model noun. Model noun. Here only 1 time, right? And model 0. And model verb. Here see the 1 time. Model verb. This is a second time. This is a third time. Right? Next see here verb. Verb contains 4, right? Here verb followed by noun. 1 time, 2 time, 3 time, 4 time. So verb followed by model 0. Verb followed by verb 0. Verb followed by and 0. This is a major. We are calculating the transition probabilities. Let's see. Here coming to this diagram. This is a model 1 time, 2 time, 3 time, 4 time, right? See here. Here calculate the total count. Sentence contains here 3 plus 1 plus 0, 0, right? This is a total 4, right? 1 plus 3, 3 plus 1, that is a 4 plus 5 plus 4 is a 9 and 4. Same like this we are applying by dividing the sentence by count, right? 3 by 4, 1 by 4 and 1 by 9, 3 by 9, 1 by 9, 4 by 9. Like this 1 by 4, 3 by 4. We are calculating the emission transition probabilities and emission probabilities like this. This is followed by, you can calculate also tag sequence probabilities like this. So in this session we discussed about the HMM for POS tagging, how we are applying the probabilities to the words. Thank you.